All right. So welcome to another session with the Portland Python Pirates. My name is Chris Thompson. We've been doing a series on Docker and Kubernetes. So hopefully a lot of people have been able to, we haven't touched Kubernetes yet, just to be clear. We've done Docker, we've done Docker Compose. I'm not going to do a recap of Docker tonight. So if you're a little fuzzy on Docker containers, go back and watch the first session and it should set you up for like what we're talking about today. Not that you can't get something out of this session. You don't have to know containers in order to understand tonight's session. It will just inform, like give you a better background as to what is happening and why we're doing this and what's going on. And I haven't, unfortunately, sorry, gotten the video up for the Docker Compose on the YouTube channel from last week. So I'll get both those videos up, this video and the Docker Compose session up, in the next couple days or so. I'm only one man, but anyway. Again, tonight we're going to be talking about dev containers. This is something that I've discovered fairly recently and use pretty extensively at work. And I wanted to share it to give some context on containers and how you might be able to utilize them just every day. Because I think that a lot of times they're seen as something used in production and like for applications, but you can actually use them for development too. And I've done it in the past, but now they've created a nice ecosystem around using them specifically for that purpose. So we'll dig into that tonight. So like I said, my name is Chris Thompson, first mate, Brian Holman, AKA co-organizer of the Portland Python Pirates. I'm not sure if he's here tonight, but nevertheless, huge help, and shout out to him. Guiding principles, we're inclusive, we're Python focused. We try to do progressive learning. So like this Docker series, for instance, we started really simple with Docker containers. And we've kind of been progressing with our knowledge, going from a single Docker container to multiple Docker containers using Docker Compose. Tonight we're going to talk about dev containers, which is a little bit of a sidestep, but also a little bit more complex. And then finally, the grand finale will be Kubernetes and scaling applications or containerized applications. And then we're collaborative. So if you have any questions, feel free to raise your hand, drop it in the chat. I'll be monitoring that throughout this presentation. And we'll try to get that answered when we have time. I see in here now. Voice not as clear as your background. Oh, can everybody hear me okay? Is the sound okay? I can take my headphones off if it helps. We're good? Okay. All right, I'm just double checking. If it gets weird, let me know, because I'll just keep rambling until this is over. So please speak up. All right, so again, we're gonna do a little bit of an overview of VS Code extensions and then dev containers, and then we'll do the demo, set up the dev containers. Loosely follows that format. I was a little hectic. It was a little hectic this week, so this might feel a bit less structured. But I always try to find memes related to what we're doing. So the whole point of this, right, is it works on my machine, right? This is something really common in the software development lifecycle, right? Like you and other developers are working, and this is what kind of drove my interest in dev containers. I work primarily on a Mac, sometimes on a Linux machine. Most of my coworkers are on Windows machines, and it was really frustrating to try to they pull the code from the GitHub repo, and then it wouldn't run for whatever reason. There's something weird with their computer and Docker and like all of this stuff. And I was just like, okay, stop this madness. Like, I'm going to go find a solution for this. And I stumbled upon dev containers and I've been using them ever since. Really, really nice. So shipping your machine, right? Like just put your laptop in production, and that's how we'll do it. Some resources. Again, I know I've said this every single time. I will copy this link address. I should share the Notion template address too. Here, let me just grab that. Here is the Notion template for you, kind of loosely what we're going to be doing tonight. And then I have a link to the slides on there. You can click there to get to these links, but I'll also drop them in chat right now since you all are here. So the first one is this book, Up and Running with Docker, 3rd edition. I haven't had a chance to read the 3rd edition. I've read the 2nd edition, But so I don't know if it has dev containers in it or not, but it does have everything else related to Docker. So that should really, really help you out in understanding containers. The dev container documentation is super good. I used it to get up and running, and it was very intuitive. Once you have a good grasp on containers, it should be no problem, and VS Code for that matter, should be no problem setting up your environment there. And then didn't know, but I found out this week Visual Studio Code has a YouTube channel, and they actually had like VS Code Fest or whatever their conference is, like a week ago, I think, where they kind of showcase some of the newer functionalities of VS Code. So if you're a Visual Studio Code user, definitely check that out. If you're not, this entire presentation is based around it, so you're gonna have to get it to know what we're talking about. But definitely check those links out if you're interested in learning more. Okay, so this is an image pulled from, it's the architecture diagram pulled from the Visual Studio Code documentation. You'll see it right in that beginning of it. And it's showing kind of how the dev container, what the idea behind a dev container, right? So we start over here on our local OS, right? Whether you're on Mac or Windows or whatever. You have a, the extension installed, right? And you might have some other extensions installed too, right? Like I have, I don't know, let's look right now. I have, let's see, like a Docker extension. I have the Azure extension, some other ones, right? You might have these installed. And so you also have your source code in VS Code. And so you're working locally. And that's great. When we start, when we do the dev container, right? Like when we start our dev container, it basically exposes a port from our local system into the container. And we also do a volume mount. Remember, we talked about volumes and how we mount our source code on our host machine to a container. It does a volume mount as well of all your source code. So whatever that repo or the current directory is, and it containerizes the entire thing. So it actually runs a VS Code server. And so you have the entire suite of VS Code available to you internally. And it takes care of a lot of like access to the file system, terminal processes. You can run the application, you can use the debugger, like everything is available to you inside of this container. And you're like, cool, well, why didn't I just stay on my local machine? Right? Well, here we go. So as we spoke about like at the very beginning, I run on a Mac, maybe you're running on a Windows machine. We're both working on the same application. And the usual way of doing this, right, is maybe passing around a requirements.txt. You have to create a virtual environment. You load those requirements, right? And maybe your app gets more and more complex to the point where it really actually matters what the OS is. And if you try to install Docker Desktop on Windows, you'll note, just doing that can sometimes give you a headache. And it's not like straightforward. There can be some errors, which is what we ran into at my job. And I think it was mostly due to security. I think you need to shut down Hyper-V on Windows in order to run Docker. But nevertheless, like the point is that you can run into dependency weirdness when you're switching between OS's development environments. So the reason we like to be inside of a container, remember what a container is. It's an isolated process, right, that exists on your system. And it utilizes C groups to share resources from the host system. So it is indifferent to whatever the actual operating system is that's running on the host system. We can get any OS really that we want that behaves like more or less like a full-fledged operating system, but very, very lightweight. So in developing inside of a container, what that can do for you is to give a consistent environment to those running on Windows or Mac or whatever. And you know that if it runs on your system, it's going to run on their system. And there's some even next level things you can do with these dev containers, not just like, here's a development environment, but you can stand up a full-fledged environment because it's not just one container. You can actually get an entire Docker Compose application running in the background. So in your development work, you could set up a PostgreSQL database, which is what I'm trying to do. Get our application set up with a PostgreSQL database automatically in the background, so that when we're developing locally, we have access to that database without having to do any work, right, in the background. It's just automatic. So that's kind of what I've done at my job. Is I set up. If you're familiar with MLflow, maybe I'll show that. I could show this. This is going to be right. Oh, great. Thanks, Doug. Yeah, Doug's going to drop a Docker Compose for setting up PostgreSQL. There's one in the section 2 branch. You have to go through the Notion template and actually get the Docker Compose file to set that up. But there's also an example there with the application that we've been using. Nevertheless, it allows you to set up a pretty robust environment utilizing containers and hand that to somebody else, and it will work on their system as long as they have the VS Code dev container extension and the Docker desktop installed on their their system, whatever it is, right? Windows, Mac, whatever, laptop, desktop. Slack invite link. Oh, yes. It is actually, if you go to pythonpirates.org, you'll find a link to the Slack there, and you can join through that, or you should be able to. Okay, so let's move along. If it lets me. Why are my slides not progressing? No problem. Wait. Oh, is that the only slide? Oh, okay. Well, great. I guess that's all I wanted to share. Okay, so what we're going to do is we're going to, I have a bunch of stuff open, so excuse my messiness. We're going to open a new Visual Studio Code window, and we're going to demo what this might look like. So let's say that we want to run a fast API application. We're going to be developing that. Eventually, maybe we'll have a database. For now, we just have our fast API application. So we'll, let's go in here. We'll create a new folder. Give me a second. We'll create a new folder called My App. Great. And we'll open that folder locally in here. App. Okay. Great. So now we are open. And again, this is local. We haven't done anything. And by the way, to install the extension, all extensions can be installed through the marketplace. It may already be installed for you if you've installed the remote Explorer extension, but you can go in here and check and just say dev container, and you'll get, you can check in it. If it says uninstall, it's installed. Okay. So feel free to install that. Okay, so we're going to say or let's call it good practice, main.py. All right, this is our file that we're going to install in here. Okay, and we will do a really very simple application. It's going to be a hello world application, just for demo purposes. We can get, and we'll iterate on this. But here's our fast API application. If you're not familiar with fast API, or you've never built a web app in Python, we're instantiating an instance of the fast API, right, application, and then we define a route. So we have the base route here will be, first of all, asynchronous. Second of all, we'll just give a message hello world when we go there. So we run a get, right? This is a get endpoint. And when we do a get on this, it will give us some output. So if we go, we'll run our app. Oh, right. So we're going to need to install some things in here. I'm going to create a new file. It's going to be called, lo and behold, requirements.txt. And we're going to install fast API. We're going to install Unicorn. Let me make sure that I'm doing that correctly. Fast API, Unicorn standard. Okay. And we should usually tie these to a version number. So I'm going to go ahead and do 0. It's so crazy. It's going 0.81 because this thing is used all over the place. Okay, so we, oh, whoops, typo, .81. So it may be a later version, but that's okay. This will work for our purposes. And that, and with the asterisks, we're just saying any versions, automatically update them to the latest version, whatever that is, but pin it to the minor version 8.1 and the minor version 1.8. That's ironic. Okay. Anyway, okay. So how would we do this locally? Well, if you're local, right? A lot of you have used Python, might be familiar with Python, and we use the venv command. So -m allows you to run commands in Python. So Python -m. There's some things that are pre-installed. You can run Python commands or Python code this way. And so we use the venv command, which stands for virtual environment. So this creates a virtual environment for us. I use dot just to make it a hidden file. You don't have to do that, but it's arbitrary. You can name it whatever you want. So we run Python -m, create a virtual environment .env, and you notice that created a directory here, and it's still installing some stuff. There it goes. And we can activate that by saying venv bin activate. And there's a number of different packages you can use for virtual environments. I just tend to just default to that. You can use conda, you can use pyenv, there's all virtual env, there's all these different packages. Right now we're just going to use this venv package. And so now you see that this is activated. So now we're going to make installations. This isolates it from the base installation of Python, so you don't pollute your base Python installation and perhaps get in some weirdness, right? So you can absolutely obliterate this environment and it won't affect your base install. So always best practice to be working inside of a virtual environment. All right, so we install our requirements by saying, we don't do that. We say pip install Python, pip install -r for recursive, and our requirements.txt. Requirements.txt, by the way, is just that it's not required that it be called requirements.txt. That's kind of an agreed upon practice. So call it whatever you want, but requirements.txt is usually what it's called. And we install those in our virtual environment. While we do that, check the chat. Yeah, great. Yeah, we'll get there, Doug. Yeah, so I'm not going to be working on multiple projects inside of this environment. I'm going to be working on the same on just this app alone, and we'll get there as we get into the virtual or the Docker container. I'll show you why this is useful, and we've kind of touched on it a little bit. Just again, if I'm on a Windows machine or if I'm on a Mac and my development team is working on Windows and maybe somebody else is on a Linux or whatever, right? Like this can be a really great way to create a consistent environment for everybody to work out of. And it's still a little vague, right? Like we haven't even started the dev container. I'm just trying to set this up to show you the difference between virtual environment and like a dev container. I'll try to hammer this point home. I know it seems a little weird, but hopefully we'll get there. Okay, so now we have Uvicorn installed, which is a web server. Python doesn't natively know how to speak the language of the internet. So we have these, this is an ASCII server and asynchronous. I always forget what SCII stands for. But essentially we're speaking, someone can post it, asynchronous something interface. This is to allow it to speak the language of the web, right? HTTP protocol in this case. So we say Uvicorn main app. So we're saying in the main file, which is here, run the app, which is defined there. So that's all that is. And we'll say reload. We don't need to. That's so it'll continuously monitor for changes in the code base so that you don't have to stop the server. You can just iterate here, right? And continuously develop. We'll run that. Wait for it. startup complete, and we should get a little pop-up here. Unless it's already up. I don't think it is. Oh, yeah, it is. That's it. I'm used to more complex logging outputs. That's why I was waiting for something else. But nevertheless, we go there and we actually get localhost 8000. So we see it just outputs the message. We sent that GET request. And you see that here. Let me move this next side by side. You see that there was a GET request sent, right? It output the log here. That was us accessing through our browser. We got a 200K. We don't have a favicon or however you say that. So it says a 404 not found. Don't worry about that. You can have that. That's the little icon that like appears up in your tab, but we don't have one. That's why you get that 404. But the message is output hello world. Great, we know it's working. One thing to note that I always like to show you is if you go to /docs with Fast API, you actually automatically get documentation for your API. So this is Swagger documentation, and you're able to try it out straight from the browser. You get the curl command, outputs the curl command, it gives you the response body, all that stuff. And as your APIs progress and get more complex, it'll output more codes here and so on and so forth. So great for documentation, and there's lots more configuration you can do here to make this really robust. If you look at the application that we've been using in the other tutorials, you'll see that it can get, that it's really, really nice for customizing your application documentation, and saves you a lot of time because we all hate writing documentation. At least I do. I don't know anybody who does, but if you do, more power to you. All right, cool. All right, so we have a working application. Maybe this application doesn't, right? We want to make sure that it works everywhere. And right now, it sort of does, right? Like we can assume that it does, but remember that it's running on the host system, which depends on all the things that go on a host system. We don't have a whole lot of control over what happens on our colleagues' machines, right? So maybe they have some customization or something that they've done that would cause this app to fail. So, you know, differences in development environments, to kind of circle back on what Doug was asking earlier about our why are we using a dev container if we're not working on multiple projects. My feeling about dev containers is that you actually don't want to work on multiple projects. That's the whole point. If you have multiple projects that have different dependencies, right? So maybe you're working on something, a front end, a whole different application with TypeScript and a whole set of different dependencies. And then maybe you're also working on a Python application that has a whole set of different dependencies. Maybe you're working on multiple Python applications that have different versions of Python that they need, right? Well, installing different Python versions on a host system can be a little bit cumbersome, and you can run into some serious like issues, and debugging those and untangling that web of chaos. If you've ever done that, right, is not great. And yes, you can use virtual environments, but again, a virtual environment is not exactly portable in saying that I can't customize a virtual environment easily and share it with my colleagues, right? You can use things like, you know, dependency, things like poetry is one that comes to mind, right, for dependencies and things. But again, that becomes a kind of a you know, a risk when you start talking about switching environments. And by environments, I mean switching OSs between, say, I'll just use the example because it's most popular, between Windows and the Mac. And we want to mitigate that risk as much as possible to keep developers productive and happy. And so that's kind of in a nutshell. Hopefully I'm explaining that right in a way that makes sense, why you would use them. I distinctly remember an angry thread about poetry and ML Python. I'm sure they exist. Yes, it just gets really complex, right? And when you're talking about portability, like you just want things to work, right? And so so I'll show you that now. Let's do a dev container, and I'll show you how easy this is. All right, so there's several different ways, and in the Notion template, you'll notice that I just show you how to just like open folder in container, choose Python 3, install some things. But what we're going to do is customize a little bit here. That's a very basic way to open a dev container. I'm actually going to add the configuration files that we need and show you how to do that. So here we go. Okay, so I click, by the way, we're in the command, what do they call it? The command palette here in VS Code. You can use on Windows, I believe it's Windows Shift P. On Mac, it's Control Shift P or something like that. Command Shift P, something like that, and it'll get you here. Or you can go up to the, go up here to where is it? View, and come down here to command palette as well, and you'll see the shortcut there. So anyway, we're in here. We go to add dev container configuration files. And we scroll down. Notice there's all these different, right, configuration templates that we can use. There's a Debian container with Git installed, universal Linux container. So these are all containers. If you need to do Docker and Docker, so you're running child containers inside of a container, which is, the definition of inception, you can do that. There's all these different ways, Kubernetes and so forth. What we're going to do is just run a simple Python 3 container. Go there. And we'll do, we'll go with whatever our base system is, whatever our environment is. So actually, let's check that out. So you can run Python -- version. And you see I'm running 3.9.6. You can specify that when you start your virtual environment. You can say use a different version of Python. We're not going to do that. We're just going to go with what I have installed, which is 3.9. So we'll choose 3.9 bullseye. This is going to be a Debian container. And then it asks you first to select additional features. So there's a whole host of stuff that you can just install on here. You can get an Apache Tomcat server, right? We can get just app packages, so on and so forth. There's a million of them. I'm not obviously going to name every single one. So we'll click OK, but note that you can add any of these, and these are all maintained. These are all like official, right? So there's R, there's Terraform, there's all kinds of stuff. And so we're going to select OK just to keep it simple. And notice that it adds this .dev container directory, and we have a dev container JSON. Great. So this is our configuration file, and this is what I wanted to look at before, and there's a reason for that. So it starts off at the top. This is the name of it. We could call it whatever we want, like Pirates app, right, or whatever. Here's the image that we're going to be using. All these images are maintained, or a lot of these images are maintained by Microsoft themselves. So they're consistently updated and scanned for vulnerabilities and things. I would suggest using this at least as a base image, right? You can always build a custom image on top of these images, but it's always good to use something that's officially maintained. If you're not doing your own vulnerability scanning, which if you are, great, kudos to you. And you can configure that in Docker Desktop. But I usually like to rely on the big boys unless I really, really need something customized that they don't offer, or something super lightweight. Note that these dev containers shouldn't probably be used in production. They're very heavy and have tons of a huge attack surface because there's so many features installed in them. So these are not for deployment. This is purely for development. But try to find an officially maintained container before you venture out and try to create your own, or build on top of one that already exists, which will also give you the same benefits. And so here's the features. Remember, we didn't add any features, but we could add all kinds of things. One example is if you saw our series on, well, it wasn't a series, it was just a tutorial on pre-commit hooks for Git. That is a great example. You can install pre-commit hooks into this, and they have features already maintained by a lot of the, there's a whole host of them. If you go to containers.dev/features, you'll find a whole list of features that you can install. There's lots of cool ones, but I did a lot of my pre-commit hooks. You can install those here. and you can port forward. So there's an instance where I need, if there's an instance where I need access to something that's running inside the container from a browser on my host system, I need to forward the port from inside the container to my host system to be able to access that on the browser. So if you need to access on the browser for whatever reason, in this case, right, if we wanted to access that documentation, great example, we would do that here. So if we go to forward ports, and we forward port 8000, right? And this is because there's no comma here. There we go. We should be able to access our documentation from our host system once it's, we haven't spun up the dev container yet, just so you know, but we will be able to do that. Okay. There is a post create command. So sometimes there's things you want to do after your container is up and running, right? So it spins up the container, and we want to say here, install some requirements. So we're going to uncomment this, and that's kind of why we created that requirements file. So as dependencies change, and we change that requirements file, when this environment spins up, it will automatically install those requirements. There's some customizations that you can do here. We're not going to be doing anything with that. And then if you need to connect as root, then you can do that. We don't need that, and that's usually for special use cases. So be really sure that you want to do that beforehand. It can be a vulnerability if your system is compromised and they have root access to everything, right? So just be aware of what you're doing with that. I haven't had to use it yet, but perhaps there's a reason to do that. Oh, I'm sorry. I have had to do it, but it was for a very specific reason. It was because of the configuration of my environment, but usually I don't do that. Okay, cool. Are there any questions up until this point before we start the container? In fact, we can start that now because there's going to actually be some installations happening. You go back to the command palette. It will automatically recognize sometimes that you have a dev container JSON. And so it'll pop up sometime if you have the extension installed. It'll say, hey, we noticed you have a dev container JSON. You want to start this up in a dev container? And you're like, yeah, sure. So we go to command palette and we'll reopen in container. Just by doing that, it knows, right? Reading dev container configuration, it just does that automatically. And it's starting our dev container now. We can show the log. In the log, you'll see all the things spinning up in the background, all the ports being configured for you. Here it's installing our requirements.txt. You see those dependencies being installed here. And we will wait for that to be installed. I see there's something in the chat. Make sure I'm keeping up with this. Running Jenkins container that has to run a pipeline that builds images for test QA deploy. Yes, yes, exactly. Okay, and we are, oh, and by the way, that comment in the chat is Docker within Docker. A good example of that is running Jenkins container that has to run a pipeline that builds images for test, QA, deploy, etc. Totally true. If you've ever used something like Google Cloud Build, they're actually using containers to build containers, right? From inside. That's actually what's happening if you're using Google Cloud Build. So any kind of CI/CD pipeline, that's a great reason. Okay, so our installation is finished. Now we have this environment that we're sitting in, and I'll open a second terminal here. And notice I'm in this Workspaces app. Now, if I go to my root directory, oh, whoops, my root directory, you'll notice that we have this system here. This is not my host system. We are inside the container developing. Notice my prompt is changed, right? You can customize prompts. You can do all kinds of stuff. You can input environment variables. You can have all this stuff set up so that when a developer jumps into this, it's already ready to go, right? And of course, you wouldn't want passwords and things like that. So be careful what you're actually putting into this image. But nevertheless, that's available for you. And so now what we can do, right? Now we can just run our application. So we can say unicorn main app, and we'll do reload for good measure, although we're not developing right now. Oh, watch this be. I literally, oh, my bad. I have to go into the right folder. There we go. All right, try that again. I was like, oh my God, watching me have to run as root after going through all that. Okay, so our application is complete. Now we should be able to do a localhost 1000. Okay, notice that I got this here, this 200 okay, and it's because we're port forwarding. So now I can actually still, I'm on my host system here, even though the application is running inside a container here, I automatically get access via port 8000, right? And I still can access those docs and all that stuff. And just to prove that out, we can go to our application and we can change the message, hello pirates, right? Notice that it automatically understood that we were doing that. Notice that it already understood that we were doing that. It was watching for changes, so it automatically regenerated that. And now if we go back and we say a localhost 8000, we notice that changed, right? So we're inside of this Docker container. Our app is running inside of here. Now you can also, if you go into this, if you're inside this dev container.json, right, you can also customize it with extensions. So you can add extensions that are automatically installed into this instance of VS Code when the container starts. So any extensions that you do need inside this container, you can configure those from this JSON file as well. And I'm going to show you a more complex version of something that I built. Hopefully my work's okay with this. I'm not gonna. I'll ask for permission after. But nevertheless, I'll show you something that I've done in my work that actually is much more complex than this. So, are there any questions before I show you something more complex? Is this resonating? Does this make sense? Okay, I assume it makes sense. Oh, tons of thumbs up. Wow. Okay, 100 thumbs up. Great. So, all right. So let's look at something that I'm working on for work. And it's not that big a deal because we're just going to look at config files, no code. Okay, I'm going to remove this folder from workspace. I'm going to move this guy in. Okay. Okay, so remember I was mentioning, like, I'm gonna, and I will eventually do this for the app that we're doing as soon as I can debug it, right? But remember that I said, maybe we need some other stuff, right? Like maybe we're, we have a whole environment we need set up for, say, integration testing or something like that, or running unit tests, right? We need a database in the background. We need some other server running in the background. So I'm gonna show you something right now. We'll close some of this because this is intense. Let's see. We'll close. I guess I've closed as much as I possibly can. So here I have my dev container, right? A folder, and you see there's a whole bunch more stuff than just a simple JSON. So my JSON, right? You'll notice I've defined, instead of a Docker file, which you can see here, sorry, an image, right? I've actually defined Docker Compose files, okay? And notice I have 2 Docker Compose files, okay? So this is gonna get fancy, so try and follow me on this one. Okay, so the problem we were having was we are developing on Databricks. And if you've ever developed on Databricks, you know that it's basically managed ML flow. Well, if you're doing machine learning, there's ML flow for use with ML ops on Databricks. It's managed, it's nice, they have everything set up for you. The problem we were running into was, like, we want to run unit tests and develop code because we're trying to develop an application for Databricks. And we weren't able to do that easily. Like PyTest wasn't playing nice with Databricks at the time. They're doing a lot of development, I think, in the background. Pretty soon, hopefully that will be better. Right now, it kind of sucks. And so I was like, all right, I also, and the other thing was, right, and they're also working on this, but we didn't get all the goodies that come along with a good IDE, right? Like code completions, extensions, like all of this stuff, not available on Databricks. It was just pure like text file. It's terrible. Or you have to do it in a notebook, which I also don't advocate. I mean, experimentation is fine, but I don't like development code being in a notebook. Okay. So what I ended up doing was saying, hey, let's stand up an entire MLflow environment locally using Docker Compose and dev containers. Okay, so we develop inside of our dev container, but in the background, we're connected to all of this stuff that we need for MLflow. So here's our MLflow. MLflow, by the way, again, is just an MLOps tool that you can use for tracking artifacts and versioning models and deploying models, like all this stuff, right? If you don't understand that, it's not that big a deal. We just need some back-end stuff to make our code work, okay? And so I stood that up here. We use Minio for blob storage. Okay, I'm gonna get to that. Chuba, give me 1 second, okay? So Minio blob storage, we needed something to create a bucket. So Minio is an interface that connects to backend storage, whether it's a local directory or any of the blob storage, right? And it uses a consistent S3 interface to interface with that. So it's a really nice package because you could have like Google Cloud Storage on the backend or S3 or Azure storage, whatever you want, right? It's indifferent, but the interacting with it is you use S3 no matter what, which is really nice if you're multi-cloud. So we create the bucket, it automatically does this. This container's only job is to create that bucket, so not really that important. But we also stand up a database, right? So we have a MySQL server that we spin up for the backend database. We have a web interface, so this is the server for MLflow, and I'll show you this in a second. We have Nginx, right? So we use this as a proxy server that sits in front of it, so we can just access this on, the different web UIs on consistent ports. And 9,000 and 8080, we did that for this, right? And on. We have networks involved. We have volumes. We set up this whole Docker Compose environment. If you were with us last time for the Docker Compose presentation, this should all kind of be familiar for you. And then I set up a second Docker Compose file. This Docker Compose file is simply just for our dev container. Okay, so I set up some environment variables. I have an M file I'm using. I have some a volume, right? And I utilize this Docker file. So remember I said you can customize dev containers. You can build on top of them. Here I'm inheriting from a dev container. In this case, 3.8 is what we're developing with. We installed the Java JDK because we're using Spark, Apache Spark, to do some stuff. And then we pip install our requirements. Here's our requirements file, and so on and so forth. So we create this entire environment, but we will only live in here, in this, like what this Docker file defines, in this dev container. And then if you notice in our JSON, we also have, here's what I was talking about. We install Black as a dev container extension. We install Flake 8. We install pre-commit. This is all for pre-commit hooks for Git. We have extensions that we like, right? We have spell checker, we have Python, we have all of markdown linting, like all these extensions, VS Code extensions that we installed here. You can get these, like whatever these are, these names from the marketplace. They'll give you the name of it there, and you can just add it here. We port forward on 4040 to be able to access the MLflow UI, which defaults to 4040. So on our host, we do that. And notice, yes, I do have to do root here. I forget why. I remember having to do it, and it was a major victory when I figured that out. So note that we're doing that here. Okay, so going back, I'm going to go back and answer a quick question that was asked. How do you configure the dev container to forward randomly generated ports like Kestrel server does for ASP.NET projects? Randomly generated port. That's a very good question. I don't know the answer to that. And I can't think of a great way to do that. I've not dealt with that particular problem before, so yeah. Oh, okay, perfect. Yeah, that's what I was thinking. You could probably make it deterministic somehow would be the best bet. So good on you, Doug. Thanks for jumping in there. But yeah, I don't have a great answer for that, and unless you can specify the port like Doug said. So okay, so we have this entire environment, and why did I do this? Well, what's great about this is if I just go to reopening container, you need to first save your workspace, all of its work. Okay, whatever. Did not save the workspace. All right, fine. Hold on. Okay, so we'll do file, save workspace as XML, save. Great. Okay, great. I don't know why it was making me do that. That was weird. Hello. And palette. Reopening container. This workspace can fail to open a container. Users is not a subfolder. Shared. Users C Thompson lens ML or users C Thompson lens ML that is not a subfolder. Fine. This is weird. This never happened before. Hold on here one sec. Of course it happens now, right? Oh, this shouldn't be here. Give me one sec, guys. I'm gonna, I was just working on this today. I don't know why it's changed up now. Demo day. That's how it usually goes. Container. I'm gonna move and code to okay. All right, let's do this. Rebuild without caching working. The workspace could fail to open in a container. Users, well, crap. I don't know why it's doing that. Refer to the existing Docker file on the configuration. Refer to refine container. Use base configuration for container definition. Interesting. Well, I'm stumped, and I don't want to debug this right now. But that was anticlimactic. Sometimes that happens. Let me think about this for 1 second. Open folder, add dev container, open container. The workspace could fail to open in a container. Folder users C Thompson is not a subfolder of shared root folder. Users. That's so weird. I don't know. There's some path something happening here that I'm unclear on. Dang, I wanted to show you guys what's up with that. Would have been cool. Let me try one more time. Let me try one more thing. Oh boy. I was literally just doing this earlier. It's so funny. All right, so we come in here, look at what's open. Oh, the MLflow server is running. So I should just be able to attach. All right, let's try stop everything, kill everything, turn it off and turn it back on. Stop. Yeah, you see here. Interesting. We can actually just delete everything. In fact, delete forever. Right. Everything's ephemeral, which is how you should be designing everything. Okay, let's try it again. Something weird. Keep your finger. Nope, it's not gonna let me. I don't know why. Mystery. But nevertheless, basically the reason we did this, right? Because it sets all that up in the background, and we can test our workflow with all of our code. So as we're moving through our pre-processing, as we're moving through our model training, as we're developing all this stuff, and I haven't told you what the application is. I'm not going to share too much on that, but essentially we're trying to automate a lot of the ML process through Databricks, and this is a we wanted to do that locally, again, to take advantage of, first of all, consistent environments. We also can't do pre-commits on pre-commit hooks on Databricks. So it allows us to keep our developers honest, right, in their code development. So we're all developing the same exact way, right? Same amount of white space, same amount, variable naming conventions, so on and so forth. There's lots of pre-commits that you can configure here. We can just check a couple of these. YAML, detect private keys, all that kind of stuff. This is not available on Databricks. We really wanted this to keep development consistent and keep our code consistent across developers. And so it's there on Windows, I'm on Mac, we're able to open this. Theoretically, it didn't work this time, but usually we're able to open this and everything works great. And everybody actually, after having done it this way, they are all abandoning Databricks because they're like, why would I go back? I have this great environment here that I can do the exact same thing, but I can use coding best practices. I can use PyTest. I can, be TDD, or use TDD, which is what we're doing, writing our tests and so forth. So really great when it works. Again, I'm not sure what's going on. So sorry for the anticlimactic, right, part of this, but note that you can, so by the way, I didn't explain quite why I have two Docker Compose files. I'm actually, our base dev container file is inheriting. So if you look, if we look in our dev container JSON, because I've specified this first, it's sitting on top, or sorry, because I'm setting this first, it spins this one up first, so it'll do these in order. So you could actually have an arbitrary number of Docker Compose files if you wanted. I don't know why you would have like 4 or 5, but you can specify like a consistent base environment and then reuse that for like if you're doing development versus staging versus prod or whatever. It sounds like some people are familiar with that, right? You can use this base Docker Compose to inherit from that and specify development, staging, or prod environments in the second Docker Compose, which inherits from this first. So if you're using Docker Compose, note that you can have inheritance similar to how you would have class inheritance in code, right? So you can specify a base Docker Compose environment, right? And build other environments, inherit from that environment into other environments as you need. Whew. That was a lot. We're running right up against time, but I want to be able to answer any further questions that anybody has about about dev containers. Yes, correct. The second Docker Compose file inherits from the first Docker Compose file. This is in the documentation on how to do this, right? So this is our base Docker Compose environment, and we build our dev container environment off of that. And it's mostly so that we can change our dev container environment, right? And kind of like manage these separately, right? Maybe there's a reason to do that, maybe not, but I always like to have separation concerns. So there's not too many, if there's no dependencies between them, besides the fact that it uses that stuff, I don't think it's necessary, right? Yeah. Isolation is good. And in the container world, like that's the name of the game, right? Splitting things up so that they're maintainable separately. That's kind of the joy of containers, is that as long as things have a consistent contract between them, they're indifferent to what's happening inside of the other container. So you can maintain containers separately and develop at separate cadences and whatever you need to do. And so I just kind of follow those best practices wherever I go. And I would suggest you do the same. Cool. Does the second compose file overwrite properties of the first or just adds to the first? Great question. So if we look at these, let's take a look at these top and bottom. We'll put this up here, say here, and we'll put this one down here, like that, and let's kind of clear some space. Okay. So if you see, not there, this needs to go away. Commented out. if we look here, you can see a couple of these are inherited. So let's take the AWS secret key, access key. Notice that this AWS access key is specified here. What this is actually doing, right, is utilizing this is utilizing a .m file, which I keep on my host system. The second one, and let's make sure we understand, Docker Compose, pure Docker Compose is the first file. The second one is layered on top of this first file, right? And so we're feeding in these environment variables, and this is reading from actually this container here. Okay, so this is our dev container, right? And this is our Docker Compose, just our base image, right? And so our dev container is utilizing this one, but because of the way that these are networked together, we're able to feed in environment variables, and those are able to be utilized in our base environment that we're sitting on our dev container on top of. And so to answer your question, it could go either way. You could go back and forth on that. I tend to go in towards the base environment, right? Like the base environment should be ephemeral. There should be nothing in even the configuration file that is hard coded usually, right? Unless there's some like really consistent thing. So let's we can look through that and see everything is configured. There's the password, the root password, all that stuff. The only thing we've really hard coded is this, and we could pull that out. We could pull out this MySQL URL, although it's parameterized anyway, so we don't really care about that, right? This will be consistent. It's just these values that change. So we parameterize that in our Docker Compose file. You could parameterize these. You can parameterize everything, right? And I'm a big fan of parameterizing mostly everything, unless it's never ever changing. Like I wouldn't want people to be able to change the port here, because that would just break everything, and then I'd have to deal with the headache of like, I don't know why it's not working when I ship it to somebody else. But so the other thing to note here, right, is we're actually, because we're doing this, right, we can version control our environments. Because this is all configuration files, we can put this alongside our application in a Git repository, right? And other people can utilize that. And because it's version controlled, we get all the goodies that come along with version control, right? So this is, you could almost think about this as like infrastructure as code in a way, right? It's like development environment as code. Right, so this defines what our environment our development environment looks like. It's instructions on how to build it, but it isn't actually the environment, right? But it will be built the same no matter where you are, as long as Docker desktop is running. All right, I do see we lost a few people that probably like got a little intense, but hopefully that was useful to some folks to show a much more complicated example of how you might configure like an entire environment for development containers. And hopefully you're going to go use these. I would say use these over virtual environments, right? Especially if you're working on a project together, like sharing is caring, and making it simple for your colleagues. Name of the game, they'll love you, right? And so go forth, use dev containers as much as humanly possible. Join our Slack channel. If you have any questions, feel free to reach out to myself. I don't know that anybody else is an expert yet. I hope you will be. But explore these. They're really, really cool and kind of a lesser known feature. I don't see a lot on this. And I'd love to see some other cool ways that people end up utilizing dev containers for their personal and work projects. With that, we'll go ahead and wrap up this session. Thanks everybody for coming. I hope this was useful. Be sure to sign up for next time. We're going to be talking about Kubernetes. That will be the final piece of our Docker Kubernetes journey, where we'll be scaling up a fast API application and using Kubernetes through Docker desktop. So looking forward to that. I will see you all later. Yep, and thanks for coming.